Hello, my name is Laura Hackle, and I'll be covering the new Joist Enhancements in today's webinar. In SDS2 2017, the BIM joist and the system joist have been merged into a hybrid joist that uses the pre-existing node matching, framing situation, and connection design methods that the system joist had, while offering the 3D solids generation for chord and web members and joist shapes of the BIM joist. In this webinar, you'll learn the improved setup for joists, auto standard connection setup, how to input the joist with different shapes and different panel display methods, along with many other enhancements. You can type in your questions as they come to you during the webinar, and I'll answer them at the end. If I do not know the answer to your questions, I will research them and send out a mass email afterwards with the answers. What I'm going to be covering today may differ from your screen if you're following along. These new changes will be in the next release of 2017. So in previous versions of SDS2, we've always had two types of joists. We had the system joist that would provide all the connection design and calculations, and then the BIM joist was used to model in chords and webs. It also was able to generate section cuts and erection views. Now we have the joist that has combined the two. It provides the calculations and connection design as well as solids. The BIM joist also would slow down the system, and this has improved in speed. Along with this new joist, we have auto standard connections for the joist framing situations. You can convert jobs from 2016 and prior that had BIM joist or system joist, and it will convert them correctly into the new joist add. When creating a new job, there is an option to select a joist manufacturer. Right now, we'll just leave it at default, but you could select from Volcraft and Can-Am. So if you leave it at default, it will be a combination of Steel Joist Institute standards and manufacturer data from the 2016 BIM joist manufacturers. I'll provide examples of this towards the end. So for joists now, they are added at bearing elevation, regardless of the bearing chord. This helps ensure that node matching detects the correct support every time. Users can set different bearing conditions on each end of the joist within the member edit screen. The top of joist elevations are set from within the member edit screen or using the top of joist location modifier. So there are two types of ways that you can add this in. By default, it'll add it at the bearing elevation or where there's a connection to the supporting member. Or you can use this modifier. It's located by your point locates. It will say to put the joist at the top of the joist elevation. Then you will need to use your point locate still with the modifier. If you do not have this on your toolbar, you can go to the toolbar configuration, model, and locate. Then just drag it to your toolbar. Only at member add can you select this icon on the toolbar, otherwise it will be grayed out. By using this icon, it would be similar to how you used it in 2016 and prior. You would just need to use your Z offsets, which I'll show later. So the first one I have, I'm just going to open up my model. I have some different framing situations here for my beams. I'm going to open up and then go to my joist add. By default, it will be selected to intersection of member and construction line when you first start. You'll always want to make sure that you pay attention to this, especially if you have the top of joist modifier turned on over here, which I'll get to. So I'm just going to put in my first one. Let's see. Just put it from here. I want to make sure I pay attention to my point locate. So here I'm going to just change my section size. It's going to look just like, you can just put it in just like how you used to. So maybe I'll change this to a 16K3. You have now your input elevation. So since I said it's at the bearing elevation, it automatically moved it down to 125 foot 9.5. And then if I just wanted to leave it like how I was in 2016, my input connection type, I could just change it to plain end on both sides. And then I have my connection specs. So we have our top chord to support. You could have bolted or welded. You could extend your bottom chord and then the stabilizing material that you want for that bottom chord. So I'm going to just copy this down. I'm going to take this off of plain end for the others. And I'm going to copy this down the line. So if I rotate around, you'll see that there's a joist outline now. It includes the top and bottom chord along with extensions and setbacks. So if I didn't want this and I just wanted that stick line how we used to, you can go in your display options. And display options look a little different now, but I'll go through that later on in a different webinar. And then I have my joist outline here. So I can uncheck that and hit apply. And then I just have my stick lines that are at my member line. I'm just going to turn that back on. So if I zoom in here and I hover over my profile or the outline there, you'll see that the X is going to be at the bottom corner of the shoe or where the connection is happening. If you're not getting a connection, just make sure that you turn to stick first and hover over that to see the X, where that's lining up. The target, so there's a target up towards the top, that's always going to be at the top elevation of the joist. So I'm going to use another one, and I'm going to put in a joist using the modifier. I'm also going to want to put in my Z offset. I want 2.5. And then I'm going to use this top of joist elevation modifier. So here, if I hover over my point, it says top of joist elevation is at 126 foot 0. My input elevation or input point elevation is going to be at 125 foot 9.5. So I'll do that for my first point. You'll want to make sure if you want this on, you'll have to check it on for your second point as well. And here, so it works the exact same way as if you were in 2016. You'll just want to use your Z offset there. So maybe I'll do a 18K3 there. So for my member edit screen, I'm just going to go ahead and rotate out. So you do see now that they're turned to solid. They are set to reserved. That's just going to be how they displayed now. You can change this, which I'll get to later on. So if I edit this, and so the 2017 joist edit screen is based off of the 2016 system joist edit screen with new fields added to control the shape and profile of the joist. Users can set different support conditions on each end of the joist from within the member edit screen, which we're going to cover. So here where I talked about my shape, or I guess we have different shapes. So my first one is going to be just a parallel. Maybe I want to change these. I'm going to edit this one. I'm going to change this one to a single pitch. So it's just going to have one pitch there. Change this one, maybe a double pitch. So it has 2 pitches. We have an arced chord where the top and bottom chords are arced. We have a bowstring where only the top chord has an arc there. And then I have a scissor where the top and bottom chords are going to have a pitch, like a double pitch there. And then the last one is a triple pitch. Or I guess the last one that we're going to show is a triple pitch. So it has 2 pitches, and then the third pitch is always going to be flat. The last one I have in here is a BIM custom. I'll get to that towards the end. So this would be if like Can-Am provided a XML for you that you could import in with parabolic rolls, for example. And like I said, I'll show this later on. So moving down, we have our peak offset. So let's say these are going to only become active if they're pertaining to a specific shape. So that one was grayed out. So let's say I want to change my double pitch here. So here for my peak offset, it's 25 foot. So it'd be 12 foot 6. It's just in the center. It's always going to be measured from the left end of the joist. So let's say this would be my peak. Maybe I want that to be 10 foot 6 instead. So you can see since it moved to, it's measuring from the left end, it would be at 10 foot 6 and not at the center. For the peak offset, let's say for a scissor, that would be for the top and the bottom chords. Maybe I put that at 20 foot. So that moves it all the way over there. We have our top chord radius. This would be for bowstring, and it would also be for arch chord or arched chord. We have our joist rotation. It's applied along the joist member line. The input elevations will stay fixed unless you modify them. We no longer have web normal, so you'll just need to do a rotation inside of here. Over on the right-hand side, we have a bay pitch. I'm going to go ahead and change this column here. And if I edit this joist over on the right-hand side, since it's parallel and my input elevations are the same, I don't have a bay pitch. Maybe I want to change this to 127 foot 9.5. If I tab out of there, then I have my bay pitch. And this is calculated at the top of the joist elevation at each input point. And this would be except for the single pitch joist. This will be in inches per feet for imperial, and metric will be millimeter per 250 millimeter. So if I hit OK here, it just moves it up. So our panel display method, go ahead and just edit this again. We have automatic. So this will read from the setup, which I'll get to shortly. We have reserved, which is what these look like. So for example, we left this at default. Reading from the setup, it's saying for my panel display method to leave that at reserved. We have manufacturer pre-configuration. This would be when a manufacturer provides a section size for the web information. So for example, I'm just going to close out of this quick. If I go to my utility functions, a manufacturer can send you the file, or we have one in here that you can import Volcraft and Can-Am. So if I go to my utility functions and then Joist Manufacturer Manager, Right now we have already Can-Am and Volcraft, but you could have other joist manufacturers send you their files as well. They must provide an XML file containing available section sizes and their properties that will populate the job system material file when a new job is created or a manufacturer is imported into the job. So I'm just going to go ahead and select both of these. So I'm going to select Volcraft and bring that in, and also Can-Am. So those two are going to be options now. We'll get back to these later on. So if I go back into my model, and I edit this, so we have the automatic, reserved, manufacturer pre-config. So if I check this on right now for my default and hit OK, I'm going to get a message here, a warning that just says, member 43, the manufacturer has not provided a valid pre-configured panel configuration, so a reserved panel layout will be generated. So you'll just get that message if they have not provided a panel configuration for you. So if I edit this, the last one we have is user pre-config. So what this one is, we just went ahead and converted Bruce Vaughn's parametric into our member edit screen now. So let's see, if I change this to user pre-config, and down here in the user pre-configured panel, we have a panel layout. So automatic, it's just determining automatically where to put those. I can change my panel width. I can change the number of panels and the panel point spacing. So just where those points are located at. I'm just going to set that back to automatic. And then we have our panel members. So we have our panel member material. So right now it's reading from setup, which I'll get to shortly. I could set that to angle, channel, or round bar. And then we also have our configuration. We have auto filler, thickness, and user rod. So I'm going to change this to angle. And my configuration then changes. And it can be a crimped single angle or a double angle. So if I change this to a double angle, then I also have my panel section size. I'm just going to hit OK here. And here's a user pre-configured panel. Now, where is this reading from? So if I go into my options here, job options, and then we have Joist Manufacturer setup. Expand this a little bit. So you can function without having to change anything in the manufacturer settings. So you could just leave this at default and not have to worry about ever coming in here. The manufacturer can customize this layout themselves through Python. To have something other than default, you need to import that in through using the utility functions, which we did. These will always ship with the job. You will now see if I pull down here from my Joist Manufacturer, I have Can-Am and Volcraft. You can only use one manufacturer at a time for modeling purposes in the job. So something that's very important here is if you change anything in here, it will automatically update your models update your members in the model that are not model complete. So they will get marked for processing right away. If you do not want specific joists to change the manufacturer, then you must set them to model complete. So again, if you change anything in here, it's going to update your model right away. So I'm going to change this to Volcraft. And my panel display method, I want this to be manufacturer pre-config. This can be changed job-wide or individually in the member edit screen, which I showed. So here it pops up, and just like the BIM joist, it says that you're agreeing to Volcraft section sizes and their locations for the joist panels. So I'll hit OK. This will show up in your job log if you agree to the pre-configured panel joist. So if I change to the user pre-config, then I have these different settings for the panel, which I showed you in the member edit screen. It said automatic. So we have our joist types, the material type you want for that. So like a K joist, I always want to use a round bar automatically. The rod diameter input, I want it to auto-fill the thickness or auto-filler thickness, or a user rod for the angle type, and then the angle section size. Right now, Can-Am hasn't provided anything, but they could if you ask them to. Same with Volcraft. They haven't really provided anything. That's just from 2016. So they could write this through Python and set up how they want this to show. So I'm going to hit OK here. And I get this warning here that says my manufacturer has not provided a valid pre-configured panel configuration for these member types or these specific members. A reserved panel layout will be generated. So what it's meaning here is for these specific ones, it has not provided a specific pre-configured panel configuration. Now you will see here it did provide one. Let's click OK. As we mentioned before, joists are always added at the bearing elevation at the work point, even when the top of joist modified is used. So here we have down in our member now, our top of joist is automatic. When it's set to automatic, the top of joist location can be accessed and modified by the manufacturer during process. It may also get modified during connection design based on the supporting member's dimensions. For elevation, this is automatically going to be set or selected. If I edit this one over here, when I use that modifier, it's automatically going to be selected when you input the joist. So it's saying that it's basically locked. That elevation is locked. So I wanted it to put in at 126'0". Now that elevation is locked and it will not change. We have elevation at extension ends. I'll get to that later on. This is the absolute elevation at the end of the top chord that is including the extensions. So if I had a roof situation and I knew the pitch and I knew where the beams were going to be located, then I could use this. I'll come back to this shortly though. We have our supporting chord. So this is where we want the connection to be attached to. Do we want it to be to the top chord or the bottom chord? We have our bearing shoe. If it's automatic, it's going to read the shoe depth from the material file for the section size and adjust to prevent the top chord infringement. If I have it set to depth, then it'll be the relative distance from the top of joist to the bottom of the shoe. We will come back to this. This does state the minimum of the depth it can be, and I will come to this situation later on. Then we also have elevation. The elevation is what the shoe is sitting at. So let's say I'm going to edit this and change it back down to 127'9.5". So here, as a side note, you'll see that the cap plate was formed as well. We'll come back to this later on. But if I edit this joist now, so one is seated and one is going to be a plain end here. If I edit this, you're going to see for elevation, the one on the left side is seated and framing into the column, so it is not linked. And on the right hand side, since it's plain end, or it's giving that connection on the right side, it is linked. So if I change the input elevation, then it also changes the elevation of the shoe since they're linked. So if I change this to 127 foot 10 and tab, it automatically changes this elevation to 127 foot 10. If I come in here and change the elevation of the shoe to 127 foot 9 and a half, then it automatically changes that to 127 foot 9 and a half. So what does this all mean? If I come into my PowerPoint here, so this would be showing for us a plane end connection. So this would be the top of joist elevation and the input and bearing shoe elevation and the bearing shoe depth are the exact same. So that means that they're linked there. If I do this for a seated, the bearing shoe elevation can differ from the input elevation because the shoe depth is measured from the top of the joist at the face of the supporting member. So here we have our bearing shoe depth at the face, and then we also have over here the top of joist indicator, and then the input point indicator or the input elevation. Go ahead and minimize this. And I'll come back to this message that we're getting here. So I'll hit OK. Oops. So if I come in here and snap to the surface of the shoe, here we have that they can differ. So if I change this in here from 127 foot 9 and a half, and I change that to 125 foot 10, or sorry, 125 foot 9 and a half. If I change that to 125 foot 10, you'll see here we also have our bearing shoe elevation is at 125 foot 9 and 7/8. If I hit tab here, then that changes to the elevation for the bearing shoe 125 foot 10 and 3/8. So it's just different. Over on the right hand side, we have our joist shoe depth is less than the required minimum. So if I come down here and it's saying that my minimum is 3.5 and it's set to 2.5. So if I come here to my depth and I change this to 3.5 and tab, oops, 3.5. Then it did come in. I'll scroll out here. Oops. So now it does not infringe that top chord. If I come in here, we have our profile. So the fields in here do not affect the shoe elevation. You can also specify joist profile attributes. So here we have our shoe length, and we also have our shoe pitch. So the shoe pitch is in inches, feet for imperial. This is the angle that is relative to the slope of the member. The shoe length and the pitch listed here only apply if it's a top chord bearing situation. Coming down here for my top chord pitch, I don't have an option, so I'm going to just go ahead and edit maybe a double pitch situation, or a scissor, I guess. So we have our top chord pitch, and then this one applies also for my bottom chord pitch. Now you will see that I can change these on the left side, but on the right side they're grayed out. So what that means is it's applicable to pitch joists, and it's also applicable to scissors. So it would be for this end or the left end of the joist. And then the right end is automatically calculated based on the left end's values, so they're not editable. So I could change both of these down here. And then for my triple pitch, if I had that selected, it measures from the work point of the joist and applies to the secondary peak near each end of the joist. For our connection types and specifications, we now have auto standard is an option for joists. Then we have our bolt type, our bolt diameter, and all of the same information there. So if I come into my auto standard connections, now we kind of have it broken out into different leaves instead of tabs. So if I go to joists, we have joist to beams and joist to columns. By default, if I go to beams, now all these say like web perpendicular, they also do apply for skewed connections. They just need to change the lingo there. So if I edit a joist to a wide flange beam and edit that, by default, what we have is plain end and welded. So our input connection type, I could change that to a seated or a user defined. And my top chord to support, I could have it welded or bolted. Same with all of our connection specs that we went through. Extend bottom chord and a stabilizing material. And then we have the same thing for our columns. I can go column, joist to wide flange column, and seated as well. I mentioned before that now we do a auto base cap plate or an auto cap plate for this situation. Maybe I don't want that to be a cap plate and I do still want it to be seated. All you have to do is edit this column and change that to a plain end and hit OK. And then you could still have a seated connection in there. For our bolts that I talked about in there, we have in our bolt design criteria, we now at the bottom do have it broken out into different bolt types, or sorry, different joist types for the bolts. Coming in, I'm gonna get back into the member edit screen for our setbacks and extensions, but I'm gonna go ahead and add in a joist up here. So coming down, we have setbacks and extensions. So it all looks grayed out. All you have to do is uncheck this auto. So right now it's reading auto field clearance for a quarter, which is reading from my setup. If I uncheck auto, then I can do a chord only S-type extension. So what that would do, it only applies to the top chord alone, while the full or the R-type extension applies to the top chord as well as the shoe. So we're going to do first the S-type, or the simple one. It corresponds to extend top chord, no extension, extend end option that was in the old system joist. These are all measured and from a global X value, even if they're sloping. So this will always be horizontal. I'm going to put in 2 foot here just to extend the top chord. Then I'm going to come up towards the top, and I had that elevation at extension end. Before I change that, I want to show you that it is failing, and it's saying that my depth of my shoe, a minimum is 4, and it's set at 2.5 right now. So I'm going to come up here, and I knew that this needed to be at 137 and let's say 3/8. If I hit tab, and here my minimum is set to 4 and it's set to 5 3/4. Go ahead and click OK. Now we do get the profile here for now extensions. If I hover over this, you'll see the X. Actually, I'm just going to snap to the surface of this. You'll see the X down there is going to be at the bearing elevation, and then the target is still at the top of joist elevation, so that doesn't include the extension there. Let's say I wanted this to be reinforced, so have the shoe along with it. I'm going to come down and click on the full or the R-type extension. Now you will see down here where it says shoe, it automatically grays out because it's going to automatically update as 2 foot along with my top chord. And I know that again, we have the same issue. My minimum is 8 inches and it's set at 5 3/4. I'm going to change this maybe 130 foot. I knew that was supposed to be 130 foot 10. So updated to 8 3/16. So click OK. And then we have it extend all the way. The field clearance, like I stated, comes from our setup. So in our job options, we have the field clearance information, and then we just have our joist connections, joist to beam and for seats. Here in the setbacks, down below, we have we have setback. This will always need to be in a positive value. If you're wanting it to extend, now you will need to put it in the extension area, not as a negative value in the setback. We have our shoe, like I stated. If I have it as a reinforced extension, it's automatically going to be grayed out, but I could put an extension there if it was set to something else, field clearance, and then I could also do a setback for the shoe. My bottom chord, I can just uncheck that and set a setback as well. As well as an extension and field clearance. I'm going to edit the single pitch one that I had set to plain end. If it's set to plain end, then I will have options for my bearing shoe slots. We have a slot diameter, slot length, slot edge for my near side, and for my far side. So that's all reading from my setup, which I'll get to in a second. And then we also have our bolts. You have your bolt diameter, the distance to the holes, and then the gauge. So that is reading from my standard fabricator connections. And then we have joist setup now. This is its own option instead of lumped in with the beam seat setup. So we do still have for seated connections all the same options. We have for bearing connections, I'll get to the OSHA span in a second. So what's that saying is even though if I have that set to an auto standard and the span is greater or equal to this 40 foot, it's automatically going to bolt those connections. And I'll get to that in a second. My bearing shoe slot length, that's reading, that's where the member edit screen was reading from. And then my bearing shoe slot edge distance. For the bearing shoe slot length, that is not based on the bolt design criteria. I have my stabilizer plate erection hole diameter. And then here for my joist type specific settings, we have for all my joist types, the minimum shoe length, the shoe slot diameter, stabilizer angle, and the stabilizer plate. So when I talked about the OSHA, I'm going to go ahead and add in joist here. That's 41 feet long. And I'm going to turn this to automatic, and I'm going to turn this off. If I come in here, even though that says it's set to an auto standard, and by auto standard it's reading from plain end and welded, even though that's 40 feet or higher or greater than, it's going to automatically bolt that per OSHA standard. We have Joist Reports. So reports and then Joist Report. So this is basically a bill of material for my joists. We have our report type. This would be different for what New Millennium and Volcraft need different information. So we have CB, which would be the top chord bearing length. And then we have TCX, which would be the report type chord extension and base length. We can include our member sequence, the manufacturer, and then I could just hit OK. And it gives me my information there for, so basically it's a bill of material for Joyce. For erection views, I'm going to go ahead and detail. Now for my erection views, it does show extensions here. And if I want to do, I'm going to go ahead and just add in a section view. See. There to, maybe I just want that connection. I'll call this joist section. Okay, I'm going to turn this to wire. Place that, and maybe I want to blow that up. 0.5 maybe. So here you can now do section views of it as well. And then the last thing we have are for Can-Am tools. So I'm just going to start a new job. I'm going to call this Can-Am. And then my Joist Manufacturer, I'm going to set this to Can-Am. And hit OK. Let's say I forgot. So Can-Am, they need a specific section size to be able to copy in their information. So let's say I forgot to copy that material from my seed job. To import the material from Can-Am, it must have that section size in it to be able to import any information. So I'm just going to go to my material file editor, and we are working on getting that specifically, or to come in automatically. So I'm going to come in local and then hit OK. I guess we're working on it, I should say, for the section size. I'm going to come in my angle, and the angle section size that you will need for Can-Am is, one second, I'm going to go ahead and try to find this. So you might want to write this down. It is an angle 2 1/4 by 2 by 3/16 or 0.157 to be exact. For my weight, I'll put in 3 2.25, 2.157. So this is just for Can-Am that they need this for. Just filling this information out. And 1.25. Okay. So I got that in there. Now when I go to my, so you have this different information now for your Joist default. If I had Volcraft, it would be Joist Volcraft. We have Joist Can-Am. So here, they can provide an XML containing the available section sizes and their properties, and it'll populate into this material file. So since I didn't have that specific section size in there right away, it did not import a lot of these section sizes that it needed. So I can re-import that by going to my Joist properties file and hit import. My Joist properties file, browse. We do now in your data directory, it will be called Joist_MFGS. I'll click on Can-Am and I want the Imperial. I want to replace all these section sizes, and then you can generate a report to see what's coming in. Oh, let me try that one more time. You go back into that angle. 2. Maybe I'll try 3/16. Can-Am import. Okay. There we go. So it did come in. It says now that they imported. Before it just said it failed. So it talks about all the section sizes that it was able to import because it had that specific angle in there. So I'm going to click OK here. And I'll go into modeling. And we have something now called Can-Am tools that you can add. So if I go to my options, toolbar configuration, in my command group, I'm going to come all the way down to the bottom, and it's called Can-Am tools. And I can just bring all of these over. There's a joist import. There's bridging. There's an export. So I'm just going to click OK. And I want to import in my XML file from them. This is just one that's sent with the job, so I'll just click OK, or it's sent with your data directory. You can do an X, Y, and Z offset. You can create new joists, so I'll just click OK. So I get this warning here. It's just saying they're changed, their user assigned, therefore they're not going to be broken out. That's okay. I'm going to click OK to import. All right, so now we have, if I turn this to an ISO, we have all these different types that came in with that XML file. If I turn them to stick, they still give all the joist profiles. If I edit one, it will say the shape is called BIM custom, and the panel, it says manufacturer pre-config. That's okay. And then over on the right side, it will turn it to a model complete. Saying it can't do the changes. That's okay. So maybe I want to add in cross bridging here. And there's a cross bridging clip that I'm going to surface to over here. Rotate around. Okay, I'm going to snap to the surface here. Just do 3. And I'm going to add in some construction lines. You just need 4 points to pick for this cross bridging. And when you have the Can-Am plugin loaded, over on the right or the left side for member add, there is Can-Am for member add Can-Am bridging. I can select my top to bottom and bottom to top. And here we have our cross bridging type, an X, or you can do an H. My section size, we're working on this right now, but I'm just going to pick the smallest for right now. Click OK. And so here, it puts in the cross bridging. Whoa. Maybe I wanted to select all my cross bridging. I could select that, and then I could also export this if I wanted to. So that concludes today's webinar on the new Joist member. We have now covered the merge of the BIM joist and the system joist into a new hybrid joist member. It now has the ability of the connection design that the system joist had, along with the customization and solids of the BIM joist. We now have a new setup for the joist, auto standard connections, along with new erection view detailing options.